Scene script. Ever pondered why your devices communicate seamlessly? How do your computer, smartphone, or even your smart refrigerator understand each other? The answer lies in the realm of bit synchronization. To ensure successful communication at the physical layer, two network devices must agree on when one bit stops and another bit starts. In simpler terms, they need to synchronize their bits. Two basic approaches help our devices achieve this: asynchronous and synchronous synchronization. Dive into the world of asynchronous synchronization first. Picture a sender ready to transmit data. It announces its intent by sending a start bit to the receiver. The receiver, upon seeing this, starts its own internal clock to measure the incoming bits. Once the sender has transmitted its data, it sends a stop bit to signal the end of its transmission. This approach is like a conversation where one person signals the start and end of their speaking turn. It's simple and straightforward. However, it's not without its drawbacks. For instance, the receiver's clock needs to be reset after each byte, which can be time-consuming. Also, if the start bit gets corrupted or lost, the receiver might miss the entire data byte. Let's shift focus to synchronous synchronization now. Here, both the sender and the receiver synchronize their internal clocks. They agree on when bits begin and end. A common method to achieve this is by using an external clock, often provided by a service provider. Both the sender and receiver reference this external clock. Imagine a conductor leading an orchestra, with all musicians following the same rhythm. This approach is more efficient, as it allows for continuous data flow without the need for start and stop bits. However, it requires a more sophisticated setup, and if the external clock fails, it could lead to communication failure. In a nutshell, bit synchronization plays a crucial role in networked devices. Asynchronous synchronization with its start and stop bits is simple but can be slower and prone to data loss. On the other hand, synchronous synchronization with its shared external clock is more efficient but requires a more complex setup and is dependent on the reliability of the external clock. Remember, the next time your devices communicate flawlessly, there's a symphony of bits playing in the background, all thanks to bit synchronization.